Hi everyone! In today's video I will be going over the Unit 7 study guide. So, this first set of boxes, it's the same question type, just repeated. The first one is to put it in standard form, because if you look at the original you'll notice that it's clearly out of order. Then the leading coefficient, otherwise known as the LC, whether it has an even or odd degree, its maximum number of zeros, its y-intercept, and then what does the LC, the leading coefficient, tell you about the function. So first, let's put this in standard form. So you go through and find the biggest exponent, which is 2x to the 4th. I'm going to mark that off. And then next I look for a cubed. I don't have one, so now I look for a squared. I've got minus 12x squared. And then I have a positive 3x, so plus 3x minus 4. Make sure you do this part carefully. I saw a lot of students on our quiz either forgetting signs or just dropping symbols in general, and obviously that is not fully correct. So just make sure you're writing everything down correctly. Alright, the leading coefficient, LC, if I have this in the correct order, that's just the number in front, which is 2. Even or odd degree, you look at the highest exponent because the degree is the highest exponent. And I'm going to do this in a different color. Our degree is 4, which is an even number. So even. Maximum number of zeros is the same as the degree. This means this function can have up to 4 zeros on the graph. It could have less than that, but we know it can't have more than 4. The y-intercept is the constant at the end, the number, -4. And then what does the LC tell you about this function? This might be something that doesn't quite occur to you until you have to use it later, but remember, and I kind of did this part as a hint up here, the degree tells us the type of function, even or odd, and then the number in front tells you whether or not it's positive or negative. So if we were doing end behavior, we would finish what I started up here. We would say, okay, my exponent is even, it's on the highest exponent, and then the number in front of it is a positive 2. So this is positive. So I would say at the bottom, what does the LC tell you about this function? It's a positive function. And then what that means overall, if it's a positive function, that means that the right side is up. So on the graph, the right side would be pointing up, not down. Alright, let's repeat that 3 more times. B, g of x equals negative x to the 5th minus 2x plus 5x squared. That just needs these two terms switched around. Negative x to the 5th is the highest term, and then these two are just out of order. So just a quick little note, the exponents need to go in order. I saw some students switching, especially the x and the x squared around like they were written up here. This has a 2 on it. This doesn't have anything, so it's considered a 1. The x squared is higher than just an x, so remember that. Leading coefficient, it's -1. Even or odd degree, our degree is 5, so it's odd. Maximum number of zeros, we can have up to 5 zeros in this function. Y-intercept, you look for a constant, just a plain number at the end. That would not be the 2x because it has an x on it. We actually don't have one, so that's like having a 0 at the end. So the y-intercept is 0. And then what does the LC tell you about this function? If we look at the front here, it is negative. So what does it tell me? It is a negative function. So the right side is down. Two more. C, r of x equals x cubed plus 8x squared plus 5x minus 4. This actually is already in order. Our exponents are in descending order, and that's pretty much it. So I'm just going to rewrite that as is. The leading coefficient LC is a 1. Make sure you're careful of that. Don't ever write a letter here in the LC blank. I had some of you do that on the quiz as well. The leading coefficient is just a number, not a letter. You never write letters there. So in front here, we understand that if there's a number written in front of the x, it is just a 1, and specifically a positive 1. So you write 1, not x cubed, 1. Even or odd degree. Our highest exponent is 3, which we know is odd. Maximum number of zeros. We have 3 is our highest exponent, so we can have up to 3 zeros. Y-intercept, we look for that plain number at the end. This time it's -4. What does the LC tell you about this function? Well, in front we have a positive 1. So I'm basically going to rewrite the same explanation that I did under number 1. It's a positive function. So the right side is up. Last one, letter D. F of x equals 2x minus 3x times 5 plus 2x. When you see this setup, it's your indication that you need a FOIL. You cannot put these in order right now because these need to be multiplied first. So we're going to do that first and foremost. So first you do the 2 times the 5, that's a 10. And then we have 2 times 2x, that is 4x. And then we distribute the -3x times 5, that's -15x. And then -3x times 2x, that's -6 careful x squared. Because x times x gives you an x squared. So this would be -6x squared, not -6x. And then I'm going to write this one more time because I have some like terms to combine here. You could do this in one step, combine the like terms and rearrange if you like. That's going to give me 10. And then we have 4x minus 15x. That's a -9x minus 6x squared. And then how this turned out, we have our numbers, but they're in the backwards order. Hang on just a second. I'm looking at my key and it looks like I made a mistake. I just want to check real quick. Nope, looks like my key, I actually made a mistake, so this is correct. Alright, let's continue. Okay, so these are in the backwards order, so we just have to completely reverse the numbers. So we have 6x squared, -6x squared. And then minus 9x plus 10. Now it's all in the right order. Leading coefficient, number at the front, that is -6. Even or odd degree. Once again, you look at that highest exponent, 2, which is even. Maximum number of zeros, we can have up to 2 zeros. It's our highest exponent. Y-intercept, that number at the end is 10. And then lastly, what does it tell you? You look, what does the LC tell you? Look at the leading coefficient and notice it is a negative number. So that means it's a negative function. So the right side is down. All right, that is number 1. Now we're going to move on. Number 2 deals with end behavior. Write the end behavior, so up or down. I'm specifying there because some of you will write even and negative or odd and positive, stuff like that. When we say end behavior, we really want those directions. Is it up and up, down and down and up and down? That's why I specified that. And state the number of real zeros for the functions whose graphs are shown below. So when we're given a graph, we can actually see how many zeros a graph actually has. So in behavior, this is actually really easy to see from the graph. If you look at the left side, it is up. And you look at the right side, it is up. So our in behavior is up and up. The zeros, you just see how many times it crosses that x-axis. And this does count. I've gotten that question a lot. So this is when it comes down, hits the axis, and comes back up. That's called bouncing off the axis. There's actually a reason why it does this. We'll get into that in a later unit. So it either bounces or crosses through. But it does touch that x-axis 3 times. So we have 3 zeros here. All right, B. In behavior, we're looking at the left and the right. They are both going down. So you write down and down. Don't just write down once and assume that I understand that you mean both down. Either write down and down or both down. I would take both of those. Okay. Zeros. If we look, we notice that this graph is completely below the x-axis and it never touches it. So we actually have no zeros. So you can write either 0 or none. Last one. In behavior, the left side is going up and the right side is going down. So up and down. And then zeros, count how many times it crosses that x-axis. We've got 1, 2, 3. 3 zeros. And that's it. Number 3, use what you know about in behavior and y-intercepts to match the polynomial function with its graph. Now you've seen a very similar problem to this on the benchmark study guide. What was nice about that problem is you could pretty much just cheat and only use the y-intercept to get your answers. That is not going to work this time. This time you are going to have to use a combination of the y-intercept and the in behavior from the graphs and the equations to get your answers. Now I will say 2 of them you can get the answer by just looking at the y-intercept. I'll demonstrate. So let's go through and identify all these y-intercepts first. A, its y-intercept, notice the last number. Take a step back. Notice these are all in standard form. They are. I'm going to tell you that up front. So we can just look at the end and see if the number we're looking for is there. So at the end of A, negative 8x, that is not our constant. It has an x on it. So this y-intercept is 0. So this has an intercept of 0, 1. E also has a y-intercept of 0. So that's why you can't just use the intercept as your way to tell. B also has an intercept of 0. And then D also has a y-intercept of 0. And then F has a y-intercept of negative 5. So notice C and F have different y-intercepts from everything else. So I can quickly go ahead and identify C and F because I know that they are the only ones with intercepts of 1 and negative 5. To figure out the other 4, I will have to use in behavior. So let's just go through and identify those really quickly. So we're going to find our y-intercept on each graph. Graph number 1 has a y-intercept of 0. Graph number 2 has a y-intercept of 0. Graph number 3 has a y-intercept of 1. Now, I know for a fact that has to be equation C. So, graph 3 has been used. Graph 4 has also a y-intercept of 0. Graph 5 has a y-intercept of 0. So graph 6 must be the one that goes with F. Negative 5 is my y-intercept, and that does match equation F. So that's graph number 6. So I've already eliminated those two. Now again, the other 4, I have to use what I know about in behavior to match them up. So I'm going to go through and identify the in behavior on the graphs first. That's pretty easy to do. So on graph number 1, we have down on the left side and up on the right side. So we have down and up. And then let's put this back in terms of even, odd, positive, negative, because that's how I'm going to tell from the equation. So, down and up, these are opposite directions. That means this is an odd function. And then the right side is up, so that tells me it's a positive function. Ends up, so it's positive. All right, graph number 2. We look, and they are both down. So down and down. When they're the same direction to the left and the right, we know it's an even function. And then both down, it has to be negative, because negative goes down. But specifically, again, that right side tells you whether it's positive or negative. 2 more. Graph number 4. We notice that these are both up. So this is the exact opposite of graph number 2. We have up and up. Once again, same direction tells us it's an even function. And then since it's up, of course, it has to be positive. But specifically, the right side is up, therefore it's positive. So by process of elimination, the only one we haven't used yet is odd and negative, so you can assume that's what this is, graph number 5, and it is. The left side is up and the right side is down. So we have up and down. These are opposites, so that means you have an odd function. And then the right side specifically is down, so it's negative. So now let's identify even, odd, positive, negative for our 4 equations and then match them up with their graphs. So graph A, again, these are in standard form, so I can just pay attention to that first term. Our degree is even, and then our number in front is just a positive 1. It's even and positive, so that matches with graph number 4. E, look at that first term. It is odd and negative. So that goes with graph number 5. Two more. B is odd, which at this point, I mean, we have an even function and an odd function, so you could stop here, but let's just make sure, because we could have made a mistake. The number in front is a positive 1, so again, it's positive. Odd and positive, that does match with graph number 1. So then again, by process of elimination, D is to be graph 2. Let's just do a quick check. Look at the first term. Has a degree of 2, which is even. And then the number in front is negative. And that does match graph number 2, which is even and negative. So I feel pretty good about that choice. All right, moving on from in behavior, we're now going to get to equation stuff. Number 4, given the roots of the polynomial, write the equation of the original polynomial. This is the very last thing that we did, notes-wise, for the unit. So even though it was pretty recent, we didn't spend that much time on it, so we don't remember how to do this. So remember, what you do is you start with the roots, and what we're doing is trying to get back to the equation. So we spend most of this unit breaking down polynomials, but this allows us to go backwards. Let's start with just the broken down numbers and get back to the full thing. So they actually already give us the roots. X equals 0, x equals 4, and x equals negative 3. Then you want to write them as factors. Once again, I will show you one time through how this works, and then after that, on part B, I'm just going to make the switch automatically. So, what we want is we just want our factors equal to 0, so I'll demonstrate with the last two first. So if I move this 4 over by subtracting, this is x minus 4 equals 0. Move the negative 3 over, this becomes x plus 3 equals 0. And then I can write them as their factors. Just the x minus 4 and just the x plus 3. So essentially from root to factor, all you're doing is changing the sign. Now with the 0, it doesn't matter how you do it. I'll go ahead and show you that it ends up just being an x, if you remember. That's because it's already equal to 0, so you don't need to move it. But if you were to move the 0, it would, if we subtract it over, look like x minus 0 equals 0, which looks kind of silly when you think about it. X minus 0, you're not changing anything, it's just x. You could also say x plus 0 here. It would still be x. So if you see x equals 0, you just write x. You could write x minus 0 or x plus 0, but that's going to create quite a bit more work for you later when you're multiplying it through. That's why we recommend just writing the x. Alright, once you have your 3 factors, then you just multiply them out. And you will be using the FOIL process here. So I'm going to put them all together. We have x, x minus 4, and x plus 3. Again, my general recommendation is you multiply the back 2 first. This is so that you keep the front term there because you end up either foiling or distributing it later so that it just looks the way we're used to having it. So I am going to multiply these two together first. Again, you can do these in any order you want, but that's just my suggestion. So we do x times x, that's your first step. X times 3, that's your second step. So we do those first. And don't forget to bring the x down as you go. That is extremely important. If you forget it, more than likely you will completely forget to use it. X times x is x squared. Careful there. X times 3 is 3x. Minus 4 times x, that's our third step. So minus 4x. And then minus 4 times 3, that's our fourth step. That's negative 12. Once again, when you FOIL, if you do it in that order that I just showed you, then the middle 2 terms can be combined. You'll always have 2 terms that need to be combined, but if you do them in that specific order, they will always be right in the middle together. X times x squared. 3 minus 4, that gives us a negative just x, or 1x if you prefer. Minus 12. Now, when you have just an x on the outside, this is your easiest possible scenario because you just have to multiply by one thing. So now that I'm done foiling, I just have to distribute that x through. And notice, here we've got one thing to multiply through, not 2. So I'm not going to go back through and do it again. Just do it one time. X times x squared is x cubed. X times negative 1x is x squared, negative x squared. You can drop the 1 at this point if you want to keep it, that's fine. I'm not going to. X times negative 12 is negative 12x. There is my final answer. B. Once again, you start with your roots, which they have given to us. X equals negative 3. X equals negative 1. X equals 6. And then you make them into factors. So again, I'm not going to show the setting it equal to 0. If you want to write that out, that's fine. But I'm going to turn them straight into factors. That gives me x plus 3, x plus 1, and x minus 6. And then now I multiply. Once again, you can multiply these in any order you want. I'm just going to keep them in the order that I had them and then multiply the back two together first. So x times x is my first step. X times negative 6 is my second step. Then I distribute the 1. So 1 times x is my third step. And 1 times negative 6 is my fourth step. So first, bring down that x plus 3 so you don't forget about it. X times x is x squared. Be careful there. X times negative 6 is negative 6x. 1 times x, that's just going to be a 1x. And then 1 times negative 6, that's just negative 6. Now, a lot of students at this step will go ahead and start working with the x plus 3 and multiplying it through. You can do that, but reminder, don't forget to combine these like terms first, because if you don't combine those first, you're going to have a bunch of extra terms that you wouldn't have after you multiply this through. Basically, it's going to create less work for yourself if you go ahead and take care of this. So combine those like terms. X squared, and then negative 6 and positive 1, that's negative 5x minus 6. Now I'm going to work with the x plus 3. Now a reminder, this is where FOIL kind of falls apart, because FOIL works when you have 2 things each. Now we have 2 things and 3 things, so it's going to be a little different. But the process is still the same. The idea is still the same. Multiply the x through first. So x times x squared, x times negative 5x, and then x times negative 6. So I'm going to do all those first. X times x squared is x cubed. X times negative 5x is negative 5x squared. X times negative 6 is negative 6x. Now I multiply the 3 through. So I have 3 times x squared, that's going to be a positive 3x squared. 3 times negative 5x, that's negative 15x. And then 3 times negative 6 is negative 18. From here, I have to do 2 things. I have like terms I need to combine, and I need to put it in standard form. So I'm going to do that in one full swoop. For this, I am personally taking a pencil. Here's that trick I've shown you before about marking things off as you go when you write your answer. It really helps keep track of your terms and helps you not forget anything. Now, this is why I recommend the order of things that I do, because I ended up having my highest term in front. So I don't have to go finding it. It's the x cubed already in front. So there's my x cubed. Next, I'm going to look for squareds, and I have 2 of them. I have negative 5x squared and positive 3x squared. Negative 5 and positive 3, that's negative 2x squared. And I look for x, and I have two of them, negative 6x and negative 15x. Negative 6 and negative 15, that's negative 21x. And lastly, I have negative 18 at the end. And that is my final answer. Next page. Given a polynomial and one of its factors, find the remaining factors of the polynomial. So this time we are doing our general process of breaking down the polynomial and finding the factors. First off, it mentions factors, and it wants the remaining factors. Remember, that affects your format. So x plus 5 here, that's a factor. And if you remember, that means you change the sign when you do the synthetic division. I'm going to zoom in real quick. So, like I said, with the factor, one, that means you change the sign on the 5 when you do the synthetic division. And all you have to do to get to your answer is factor, not factor, and solve, like with zeros. We'll get to that in number 6. Okay. We create a little bit of separation here. So, first thing off the bat you do is synthetic division. We have an x cubed. We can't factor that, so that's why they give us the x plus 5. So, let's set up our synthetic division. And before I do that, just caught myself, we go through and we make sure we're not missing anything. I always like to write this out a second time if we are missing something, just so I can see what I need to include. X cubed, 7x squared, x. Notice we don't have a no x term, a constant. This is important. You can't leave that out. So I'm going to rewrite this. X cubed plus 7x squared plus 10x plus 0, because we are missing that constant, and we're dividing by x plus 5. Now I've accounted for everything, I can jump into the synthetic division process. So first thing you do is you change the positive 5 to a negative 5. This is a factor, so you do change the sign. Negative 5 goes in the division box. And then our coefficients, we have 1, 7, 10, and 0. If you leave off a 0, it will affect your final answer. Bring down the 1. Negative 5 times 1, that's negative 5. And I will go ahead and write out the steps here for those who need it. 7 minus 5, that gives us a positive 2. Times negative 5 gives us negative 10. And I forgot to write the add here. 10 and negative 10, those do cancel and give us 0. And then 0 again times negative 5, well, that's still 0. And then 0 plus 0 is 0. So, 1, 2, 0, 0, that's what comes out of the synthetic division. First off, this is our remainder. And we got a remainder of 0, which you have to get a remainder of 0 on these problems. It tells you this is a factor. So for that to be a factor, this has to equal 0. Plus, if you didn't get 0, you wouldn't be able to do the next step anyway. Now let's go through. We have no x, x, and x squared. From here, we set up the depressed polynomial, the dp. We have 1x squared, or just x squared, plus 2x. And then we have no x and it's a 0. So I'm actually going to leave it out I will show you an alternative method for solving in a moment if you need it, but I'm going to show you actually the easier one, which is this one here. So you have your depressed polynomial, and then what they ask for next are the factors. So when it says factors, all you have to do is factor this. That's it. So we have x squared plus 2x. Now these are easier to factor because there's only two terms here, and the only thing you can do is factor out a GCF, which we do have a GCF. We have a GCF of x. So I can divide both of these by x. Now remember that x does not go away. It goes outside, and then in parentheses, you put what's left over from this division. X squared divided by x is just x, plus, and then 2x divided by x, the x's go away, so it's just x plus 2. And then that is literally our answer. Now the other option, I'll just do this on the same paper in a separate color. So the other way you can do this, and this allows you to use an ACB chart, is you could include that 0 in your depressed polynomial. So we could have x squared plus 2x plus 0. And then we need to come up with our factors. So you use your ACB chart. So A is 1, C is 0, well that automatically makes it 0, and B is 2. Now this seems silly, but 0 is one of those numbers where you have a lot of flexibility. You can multiply 0 by anything and get 0. So it actually has an unlimited number of factors. Now I know one of those factors has to be 0. Now the only way I can get a 2 from adding 0 and something is if I have 0 and 2. 0 times 2 is 0. 0 plus 2 is 2 when you add them. So that actually does work. So we have an x plus 0 and then x plus 2, which is what I have here. Now technically it's best to not write x plus 0, but to write just x times x plus 2. You can put the x in parentheses or leave it out. It doesn't matter. But as you see, we come up with the same answer. But if you notice the GCF, I think it's a little faster. So there is another way to do that problem where you're allowed to use the ACB chart if that's what you're more comfortable with. B, h of x equals x cubed minus 4x squared minus 3x plus 18. There are no missing terms there. We do have the cubed, squared, x, no x, and then x plus 2 is what we're dividing by. So we can jump right into the synthetic division process. Change that to a -2. So we're dividing by -2 here. Our coefficients are 1, -4, -3, and positive 18. Bring down that 1. 1 times -2 is -2. Then we add -4 and -2, give us -6. Times -2 gives us positive 12. Be careful with those signs. -3 plus 12 is positive 9. Times -2 is -18. And then those are going to cancel and give us 0, which is what we need. Because on this problem we are told this is a factor, so our remainder must be 0. If you don't get 0, you have made a mistake. Remainder of 0, so we're good to continue. So this is our remainder. 9 has no x, it's our constant. -6 gets an x, and 1 gets an x squared. So our depressed polynomial, our dp, is 1x squared, just x squared, minus 6x plus 9, no x on it. From here, it's just an ACB chart problem. We do have just a 1 in front, which is the best case scenario. Not difficult to factor. So now we just find our factors. So we make our ACB chart. A is 1, C is 9, so this is just a 9. B is negative 6. So we need two numbers, we'll multiply that give us 9 and add to give us negative 6. If you can't come up with them, list out the factors of 9. We have 1 and 9 and 3 and 3. Clearly we know that 3 and 3 can get us a 6. And to get a negative 6, they both have to be negative. Negative 3 and negative 3 do give us negative 6, what we're looking for. And then negative 3 times negative 3 does still give us a positive 9, because a negative times a negative creates a positive. So we have x minus 3 and x minus 3. Once again, they only asked, I forgot to write this, for the factors, which is what I just did here. So once I found the factors, I am done. So that is my answer. All right, number 6. Given a polynomial and one of its zeros, that means that this is a 0. Find all the remaining zeros in the functions. H of t equals t cubed minus 2t squared minus 5t plus 6. We're not missing anything there. We have t cubed, t squared, t, and no t. Now this time we know that this is a 0, not a factor. So remember, that means with synthetic division, I do not change this sign. This is the number I divide by. And then when I am solving, I'm not just factoring, I also have to solve, so set it equal to 0. So this creates a little bit more work for me. So let's start with the synthetic division. I'm dividing by negative 2. Both of these pins keep wanting to go out, so I'm constantly switching. My apologies on that. Then we got 1, negative 2, negative 5, and positive 6. All right, let's bring down this one. 1 times negative 2 gives me negative 2. Now those don't cancel, that gives me negative 4 times negative 2 gives me positive 8. Negative 5 plus 8, that's a positive 3 times negative 2 gives me negative 6. And those do cancel and give me 0, which is what I needed. This is my remainder of 0. So I got my remainder that I needed, so I'm good to go there. So I have remainder, no x, x, and x squared. So then my dp, the depressed polynomial, is 1x squared, or just x squared, minus 4x, plus 3, no x on that. From here, we need to finish solving, and they want us to find the remaining zeros. So we are looking for zeros this time, not factors. So zeros means I take my depressed polynomial, x squared minus 4x plus 3. And then zeros tells you that you need to set it equal to 0. So if you see the word 0, there is a 0 involved. So this means I'm going to factor and solve. All right, so let's factor first. ACB chart, if it helps you. Let's try that again. ACB chart. A times C, 1 times 3, that's just 3. B is negative 4. 3 only has one pair of factors, 1 and itself. So we know we have a 1 and a 3 involved. To get negative 4, these both have to be negative. Negative 1 plus negative 3 is negative 4. And then when you multiply negative 1 and negative 3, you still get a positive 3. So it's x minus 1 and x minus 3. From here, to finish solving, because right now we have the factors, we need the zeros. You split and solve, set them both equal to 0. And then you just solve them. So add 1, x is 1. Add 3, x is 3. So those are the remaining zeros of the function, 1 and 3. We're going to do this one more time for letter B. F of x equals 3x cubed plus 4x squared minus 12x minus 16. And then again, this x equals 2. This is a 0. So that means do not change its sign when we are using synthetic division. And I've already read through the problem. We are not missing any terms. X cubed, x squared, x, no x. We are good. So let's go ahead and set it up. Set up the synthetic division. We have 2, 3, 4, negative 12, negative 16. First, we bring down that 3. We have 3 times 2, that's 6. 6 and 4 give us 10. Times 2 gives us 20. Negative 12 and 20 give us positive 8. Times 2 gives us positive 16, which does cancel with that negative 16. We did get r equals 0, which is necessary for this problem. Remainder, no x, x, x squared. So then our depressed polynomial is 3x squared plus 10x plus 8, no x on that. Now from here we need a factor, and as you can see there is a number in front of that x squared that is not 1, so it's going to take a little more work than the previous problem to get to our answer. So once again, they're asking us to find the zeros. So that means we take our dp, 3x squared plus 10x plus 8, and set it equal to 0. That's what zeros tells you to do. And then this is going to require slide and divide to get to our answer. So first you multiply the a times the c, and we get x squared plus 10x plus 24 equals 0. 3 times 8 gives us 24. And then we have our ACB chart. A times c is 24. We've already cleared that up. And then b is 10. So we need to come up with factors of 24 that give us 10. Again, if you can't think of them, you can always list out the factors and go from there. 24, we have 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Give those a good look. Which pair can give us 10? Hopefully you were thinking 6 and 4, because that is the correct pair. And as is, they will give us 10. 4 plus 6 is 10. And 4 times 6 is 24. So we got the correct pair. So we have x plus 4 and x plus 6 equals 0. Now, this step you cannot forget. A lot of students will completely bypass this step and then just get -4 and -6. That would be wrong. Since we had a slide and divide, we do have to bring this 3 back in to the picture. It doesn't just disappear. So this is where the name comes from, slide and divide. We are dividing the 4 and the 6 by that A again. And then we either slide or divide. 4/3, we can't divide that, so we're going to slide that 3 in front. So we get 3x plus 4. We can divide 6 by 3. That's going to give us 2, so x plus 2. Now we can solve these. So then we get 3x plus 4 equals 0. And x plus 2 equals 0. 3x plus 4 equals 0. Subtract the 4. We get 3x equals -4. And then divide by 3. X is -4/3. And then x plus 2 equals 0. Subtract the 2. X equals -2. We are done there. Alright, back page. These won't take long at all. I gave you plenty of space, but these are not as lengthy as they look. Simplify the following problems. Write your quotient as a depressed polynomial, including the remainder. So these are just synthetic division. That's it. A, 3x cubed minus 2x squared minus 150. All over x minus 4. We're going to rewrite this problem. 3x cubed minus 2x squared. There is no x term, so I need to add a 0x minus 150. And then we are dividing by x minus 4. Alright, now we can start the synthetic division process. This is written as a factor, so I do change this to +4. Dividing by 4. And then my coefficients, we have 3, -2, 0, -150. Bring down the 3. 3 times 4 is 12. -2 and 12 give us 10. Times 4 gives us 40. 0 and 40, well that's just 40. 40 times 4 is 160. And then -50 plus 160 is just 10. Now on these problems you don't have to get a remainder of 0. It's just asking you to simplify. It didn't say that x minus 4 is a factor or is a 0. So we don't know for sure if the remainder is supposed to be 0. Or has to be 0, I should say. So if this is what we get, then that's what we got. Okay, so that's our remainder. No x, x squared. So then our dp is 3x squared plus 10x plus 40 plus, when you have a remainder that is not 0, you do have to include it. It's the remainder, which is 10, over the factor x minus 4. Remember, that is the form that you use there. So this is remainder over factor. That is how you write it. All right, B. 2x cubed minus 3x squared plus 4x plus 5 divided by x plus 2. So we change the sign here to -2. And I did not check, but thankfully all of the terms are there. X cubed, x squared, x, no x, we're good. Okay, jumping back in. negative 2. And then we have 2, negative 3, 4, and 5. Bring down the 2. 2 times negative 2 is negative 4. That gives us negative 7 times negative 2. That's positive 14. 14 and 4 give us 18 times negative 2. That's negative 36. And then add that with the 5, and we get negative 31 as our remainder. And then again, we are not told this is a 0, this is a factor, so we can have a remainder that is not 0. So we have remainder, no x, x squared. So the dp, the depressed polynomial, is 2x squared minus 7x plus 18. And then we do have a remainder. Now, even though it's negative, I still recommend you write it as plus whatever. I have a lot of students that just cram the 18 with the remainder so it looks like a mixed number. That is not correct, and you will lose credit if you write it that way. So write it as plus remainder, which is negative 31, over your factor, which is x plus 2. So we divided it by up here. Now we actually changed to negative 2, but the factor is x plus 2. 2 more. C. X cubed minus 13x. So already I'm noticing we're missing an x squared, so let's rewrite that. X cubed plus 0x squared minus 13x plus 12, that is much better, divided by x plus 4. Now I can set up my problem, change the positive 4 to negative 4. And then we have 1, 0, negative 13, positive 12. Drop down the 1. 1 times negative 4 is negative 4. Negative 4 and 0, well that's still negative 4. Times negative 4 is positive 16. Be careful there. Negative 13 and positive 16 give us a positive 3. Times negative 4 is negative 12. And those will cancel and give us 0. Remainder, no x, x squared. So then my dp, my depressed polynomial, 1x squared, just x squared, minus 4x plus 3. No x on that. And then since this remainder is 0, we could technically go further, but we're going to stop there. Since the remainder is 0, you don't have to include it. Last one. 2x cubed plus 9x squared plus 7x minus 6. No terms are missing. We are dividing by x minus a half. Couple things. One, we do change this to a positive 1/2. Now, if it's easier for you, it's easier for me, I'm going to change this to a 0.5. This makes this easier to type into the calculator. You're more likely to do it correctly with a decimal versus a fraction. So please do that recommendation. So we're dividing by 0.5. And then our coefficients are 2, 9, 7, and negative 6. No missing terms there. So we bring down the 2. 2 times 0.5, this literally just means half of 2, so that's 1. 9 plus 1 is 10. Times 0.5, half of 10 is 5. 7 and 5 give us 12. times 0.5. Half of 12 is 6. 6 and negative 6 do give us a nice 0 for our remainder. So we have remainder, no x, x squared. And so our DP, our depressed polynomial, is 2x squared plus 10x plus 12. No x on that. And then our remainder is 0, so we don't include it. So this is our final answer. Alright, that's all for the video. Hopefully that answered any questions that you might have. If you still have questions after watching this, feel free to contact me via email or come see me in person. Otherwise, you have a wonderful day. Bye!